All right, we're going to quickly do these notes for 6.3. So we're taking all of those things that we just talked about, and now we are going to put them in, yes, your favorite story problems. So we're going to, again, kind of start off easy. It says the length of a garden is 3 times its width. Define variable expressions for the length and the width of the garden. Doesn't say to solve. We're starting off easy. We're just going to define our variables. Now, one way to define our variables is by simply drawing a picture and labeling it. And I think that's probably the easiest way to do this. Whenever you have a geometric figure that you can draw, that's a good way to define your variables. So let's see what it says. The length of the garden is 3 times the width. Now, one of those always has to be your x. So you have to decide which is going to be your x, your length or your width. Well, since it says your length is 3 times your width, that tells me that your width is going to be x. And then your length, it says, is 3 times that. How would I write 3 times x? Well, that is just 3x. And that's all you need to do to define your variable for that problem. And that's all they're asking us to do. We're kind of working our way up to number 3, which is a full-blown story problem. Well, let's go ahead and let's look at number 2. It says the second side of a triangle is 4 meters longer than the first side. The third side is 6 meters shorter than twice the length of the first side. Define variable expressions for the length of each side of the triangle. Doesn't say to solve, it just says let's come up with these variable expressions. So let's draw a picture. Again, a triangle is a geometrical figure, so we can draw a triangle. It doesn't really matter what it looks like. Let's say that this one is the first side, this one is the second side, and this one is the third side down here. Just so we keep our sides straight. And again, what does one of those sides have to be? One of those sides has to be x. So let's read our first sentence again, and let's see if we can decide which side's going to be x. It says the second side of the triangle is 4 meters longer than the first side. If this one is 4 meters longer than the first side, that means that our first side has got to be our x. And then if our second side is 4 meters longer than that, it doesn't say times, it says 4 meters longer, then this one is going to simply be x plus 4. So we've defined our first side and our second side using variables. Now we just have to go to our third side. Well, let's see what it says. It says the third side is 6 meters shorter than twice the length of the first side. So how would I write 6 less than twice x? Well, it would be 2x minus 6. Make sure that you don't do 6 minus 2x. Remember, way back we talked about the fact that this word flips it so the x part comes first. So this would be 6 less than, or 6 shorter than, twice the first side, or 2x. So here I've defined my variables. That's all they're asking us to do for that one. Number 3 is going to ask us to go a little bit further, but not too much. So let's read the whole thing all the way through. So it says a company's profit for the third quarter is 4 times the profit for the first quarter. The profit for the second quarter is $12,000 more than the profit for the first quarter. So all they're asking us to do for A is write the variable expressions, which means just define our variables for each quarter. So let's see what we have here. So we have 3 quarters. We have the first quarter, we have the second quarter, and we have the third quarter. And again, one of those has to be x, and we should be able to tell that by simply reading the story problem. So here we go. What does number 3 say? A company's profit for the third quarter, which is over here, is 4 times the profit for the first quarter. So the third is 4 times the first. That tells me that your first quarter must be your x, because the third quarter is 4 times that, which we would write as 4x. 2 of them are done. Let's see what else it says. The profit for the second quarter is $12,000 more than the profit for the first quarter. More than means you're going to add. So this would be x plus 12,000. And we've defined the variables for our first quarter, second quarter, and third quarter. So now let's use those. We're going to go one step further here. Write the following phrase using math symbols. So it says the profit for the third quarter minus the profit for the second quarter, and then plus the profit for the first quarter. So we're just going to take that English and transfer it into algebra. So where do I start? Profit for the third quarter, that's 4x, minus the profit for the second quarter. Now we have to be careful here. This is the profit for the second quarter. It is a binomial. We have to subtract the whole thing, so we want to put it in parentheses. Let me show you. If these parentheses weren't there, do you see where I would only be subtracting the x? I wouldn't be subtracting the whole thing. So that's why that's got to be in parentheses. So the profit for the third quarter minus the profit for the second quarter plus the profit for the first quarter, which is simply our x. So that's what they're looking for B. And C just wants us to, okay, let's take our answer for B. So I'm going to rewrite it quickly here. 4x minus parentheses x plus 12,000. And they want us to simplify it. So kind of like what we did in 6-1. So we're going to distribute through our -1. So let's see. We'd have 4x, -1 times x is -x. -1 times 12,000 is -12,000. Do I distribute the -1 to this x? No, because it's not inside the parentheses. So that's just simply plus x. Now we're going to combine like terms. So we have this, and this to combine. So 4x and a -x would be 3x. And 3x plus x would be back to 4x. If I combine all three of these, 4 minus 1 is 3, plus 1 is back to 4. And then minus 12,000. And there we go. So those are your notes for 6.3.